All right, well, let's start off with a prayer. Stop sharing. will you?
Yep.
I'm sorry, I'll get to sharing back on. Let's pray. Father, we thank you for this morning, for this day to celebrate your resurrection. And we're also going to celebrate what you made in the heavens. Amazing things that you put that we can barely see. But yet you put such detail and amazing things above us. So Lord, we just worship you this morning as we learn more about it. Repent. Stop helping me. Baptize. Zoom. Here. Like share. All good?
Yeah, the picture.
Picture, yeah. All right, I want to introduce you to our presenter today. Mr. Danny Faulkner, looking very scholarly. And they're having the other fellow is Nate Loper with Canyon Ministries. He's a geologist. These are the two guys that went on our trip with us. Danny looked at the skies and Nate looked at the rocks. And this particular place that we're at here was it was a place of the ancient, what they call them.
Is that the Indian country?
Yeah.
Yeah, where they had all
The rock carvings and
babies.
the birthing chair, they call it. I don't have that picture, but it was a rock that was shaped just in a strange way.
Mhm.
They called it a birthing chair.
I have a picture of
Yeah, I've got one too, but I didn't bring it. And they was describing what the glyphs meant and so on. So I think they're discussing dinner or something. We just wanted to see that this fellow that's presenting today, we got to know him, and he's just a very down to earth, strong Christian, real believer. If he wasn't an astronomer, he'd be a theologian, I think. I'm gonna switch to the next picture.
and he works, his office is at the Kentucky,
Oh, yeah.
at the museum there where they have the Noah's Ark. Probably get next out to have a picture and that up the movies.
All right. You have a way to switch to the next picture. Oh, that is not it. And every other's still talking. Name Danny what?
Danny Faulkner.
Faulkner.
Like a ULKN.
There he is. He's setting up his telescope there at the bottom.
And that was at our campsite, right?
Yeah, that's one of our campsites. So I'm just catching
That
up.
was a nice one.
Oh, it was a beautiful sunset that day. Did you see how the sun sets
Mhm.
across the canyon and it's just from the hills?
And what he would do is at night, he would advertise that he's up.
Yeah,
And then
with
you
his
can
laser
come with the
pointer.
Laser pointer on the face of that wall or something like that, so if you happen to blink your eyes over, which I did a number of times.
Yeah. So there's a view of the Milky Way.
Yep.
Oh, there he is. We got a couple opportunities to
Yeah,
get
we
clean.
That one took it right off your hide.
This one was a brutal shower, yes. Yeah, so he's a very happy guy. He really enjoyed the trip.
He likes Five Guys.
It's-
Oh. He went there a couple of times.
All right, let's get into the video. We're gonna sing about the Bible and stars.
Waddell, welcome to my office.
Hey, I love it.
I have the coolest job in the world, I think. I get to share my passion of the sky with people and our Creator. I get to do both of those together. This is a cool thing I do.
Oh my goodness, now you're gonna make me buy a telescope.
Yeah.
Okay, threading through part of the summer triangle, we have this faint band of light that goes up across the sky, all the way over here and back behind us over this way. It's a
Yep.
faint band of light. We call that the Milky Way.
Yeah.
And over here near the southwestern horizon, it gets thicker. Notice it's thicker over here and it's over there.
Right.
We're kind of losing that. That's the late summer Milky Way.
Yeah.
The Milky Way is a galaxy. It contains a couple 100 billion stars. It's round and it's flat. It's got a bulge in the middle. Kind of reminds me of an over-easy egg with that bulge in the center. We're about halfway out from the center, about 25,000 light years. So when we look towards this part and it gets thicker, we're seeing that bulge near the center of the galaxy. When we look over here, we're looking 180 degrees away. We're looking directly away from the center of the galaxy, so it's
Okay.
not quite as bright. This is the summer and autumn Milky Way. This is the beginning of the winter Milky Way showing up over here. You know, for us in the northern hemisphere, the Milky Way never gets, at least the center doesn't get very high in the sky. Sagittarius, you can see early in the evening here yet. It's prominent in the summertime, and that's where the center of the galaxy is, and it's never very high in temperate latitudes in the northern hemisphere.
Well, to me, the Milky Way has always been the most fascinating thing. There's something about it that just almost stirs you when you see it.
Well, you know, most people never see it the way God intended it because of can't get away from the city lights where it's dark like
Right.
this. But I found when people get to a dark site like this and they let their eyes get a little bit dark adapted, they're stunned. I've had people gasp when they see the Milky Way for the first time.
Well, Danny, do you think, is that the reason God made it? Which is amazing to
Yeah.
be in awe. Do you think
Well,
that's why God made all of this?
Yeah, I think a good part of it. You know, we have some purposes given for the stars in Genesis 1:14-19. It's a day 4 creation account. It mentions the stars and other heavenly bodies to mark time, to rule over the night, to be for signs, for marking of time passage, seasons, festivals, and so forth. But Psalm 19 also tells us the heavens declare the glory of God and the firmament showeth his handiwork. And it's like a billboard that I think is advertising that God exists. He's powerful. You know, Psalm 8, Psalm of David, and he says, you know, when I consider the wonder of your hands, the sun, the moon, the stars that you've made, you know, what is man that you're mindful of him, the son of man that you regard him. You know, he was a shepherd, and he spent a lot of nights, I'm sure, watching the flock. He's probably doing it from 2,000, 3,000 feet elevation in the Mediterranean climate, a lot like we have out here. And all he had was 2 eyeballs that he was using. And that really brought him close to his creator. And that's one of the neat things about astronomy. I think one of the things that always have impressed me is the fact that I see the handiwork of God in this.
Well, Danny, beyond the beauty of what we see here, do you see purpose for what God has done as well?
Well, yeah, I think the size of the universe, it demonstrates his mighty power. You know, Romans 1 tells us that the world around us speaks of the fact that there's a creator and he's very powerful. That's all it tells us, by the way. Can't get specific information about our creator, but it does tell you there is a creator. And that's one of the big messages. But you know, there are other purposes like timekeeping, and there's a bright star. We'll stay up late enough tonight. We'll see it. Sirius. It's the brightest star in our sky. It's called the Dog Star. In ancient Egypt, they saw it rising before the sun did. You go behind the sun in spring, late spring, and then emerge in early summer, midsummer, and behind the sun's glare. And they first spot it in the morning, and that coincided within a week of the Nile River flooding. And when it did, it flooded its banks, and they could tell when they had to prepare for planting the crops because that would re-nourish the soil, and they had to be ready for that. And this became known as Dog Days. Goes back to ancient Egypt.
Yes.
And it comes from the Dog Star. So people have been using the stars for marking passage of time. And we have, you may have heard of astrology and the zodiac, and these are 12 constellations along the apparent path the sun follows and the moon follows and so forth. They've perverted that into fortune telling sort of thing, but actually those things have a useful purpose for reckoning time on small and long scales. The month is determined by originally at least, by the phases of the moon. You know, the Hebrews still keep, the Jews still keep a lunar calendar. We have a lunar solar calendar. We have a solar calendar, so we've have over 2,000 years ago, abandoned the days of the month staying in sync with this moon's phases. But on the 15th day of the month on a lunar calendar, it's always a full moon. And you know, the big feast like the Passover falls on a full moon because of that reason. It bounces around on our calendar, but it's always on the 15th day of that one month, the first month of their year. on a lunar solar calendar.
So were all those festivals tied in again to?
They
to-
were tied to these things. Apparently, the first Passover in Egypt happened at a full moon. It's interesting that if you read it very carefully in Exodus, it says that Pharaoh had enough when his firstborn died.
Yes.
He called Moses at night and said, "Leave now." Forget what you saw in the movie The Ten Commandments. They didn't leave in the middle of the day. They left at night. Now, you're a pilot. You've been out at night. How well can you see when the moon's full?
When it's full, you can see a lot.
Very well.
can
But
see
if you don't have trees overhead like we have here in the desert and they have in the Middle East, they actually started their trip at night with a full moon.
Under a full moon.
And so in order to commemorate that, for past 34 centuries after that, they always commemorate it on the anniversary of that, which is the full moon after the first month of Aviv in the spring. And so it really is on the anniversary on a lunar calendar.
Well, Danny, what you're explaining to me is that it's not just a beautiful sky, but it's a very ordered sky. There's a lot of order that's going on here.
The patterns repeat every night. They repeat every year. They come back in their season. There's a lot of regularity going on here. It's truly remarkable.
We have been talking earlier about the concept of irreducible complexity when it comes to biological systems. Would it be fair to apply that same kind of a term to what we're seeing here?
Well, it's a really tricky thing because living systems are a bit different from what we have here. I've been wrestling with this idea of design in astronomy for a long time. I think some creationists, some biblical people maybe see design where there isn't any sometimes, but I do see design here. I find it incomprehensible to me that this is all just an accident. Like the moon, the more I study it, the more I'm impressed with what we see there.
What do you see when you
Okay,
look at the moon?
the moon's different. we have like 170 satellites, or natural satellites orbiting planets. Jupiter and Saturn have scores of satellites orbiting them. We only have one. Most of the satellites are small, but Jupiter has 4 large ones, Saturn has 5 or 6 fairly good-sized ones, and the Earth has a good-sized one too, even though there's several larger than it is. But the moon's orbit is different. It's a little tricky. I'll try to explain this best I can here. The sun is 400 times larger than the moon. So if you had a ball the size of an inch across, that would be the moon, and the sun would be 400 inches across.
Wow.
Gives you a bit of scale.
That's not what we see, though.
No, because you see the sun is not only 400 times larger than the moon, but it's also 400 times farther away. So if you take something and move it as far away as it is larger than the other, they have the same size to us. Both the sun and the moon appear to be about a ½ degree across in our sky. Now, on rare occasions, the moon passes between us and the sun. Doesn't happen very often, about every year and a half somewhere in the world, usually in Timbuktu. And when that happens, the moon just barely covers the sun up. If the moon were a little smaller or a little farther away, it wouldn't do it at all. If it were larger or closer to us, it would be grossly over total. Wouldn't be nearly as spectacular. We get these rare and very spectacular eclipses.
Do you think that's a design that
Well,
God gave to us?
it's the if you look at the other satellites, 170 or so in the solar system, none of them have those kind of requirements. Either they don't happen at all, or they're grossly over total, so they're not very rare and they're not very spectacular. It takes. I read once that on a given place on the Earth, we get a total solar eclipse about once every 400 years. So either if you see one, you're either very lucky or you plan to be there to see the thing. And so these eclipses are spectacular and rare, and this is the only planet on which it matters, and it's the only planet on which it happens. I don't find that to be just a coincidence. I think there's more to it than that. But there's another more important thing about it. The moon's orbit is different. We have the plane of the Earth's orbit around the sun. We call this the ecliptic. Imagine a flat plane here. The sun's here, and every year the Earth goes around like this, and it causes the sun to seem to move through the stars. That defines this ecliptic across the sky, this big line across the sky, the plane of our orbit. Now, the moon's orbit is very close to that plane. It's tilted a few degrees, but basically the moon orbits around the Earth in the same plane that the Earth orbits around the sun. Of the 170 or so satellites in the solar system, it's the only one that does that.
Is that right?
All the others have different orbits. The most common type of orbit is above the equator of what we call the equatorial plane of the planet. And each of the planets have different tilts. Our own tilt, our own Earth's tilt's about 23.5 degrees. So if this is a plane of the Earth's orbit, there's another plane, the equatorial plane, that's tilted 23.5 degrees to that. And if the moon were like other satellites in the solar system, it would be orbiting in this plane, not in that plane. But the interesting thing is, that tells me something right away, that the origin of the moon must be different from other satellites. It must be unique, which we kind of know that from Genesis because the purpose is involved. I believe the moon is unique, and the origin scenario perhaps would be unique as well. And, you know, astronomers have tried to claim, well, we need to study the satellites of the other planets, hopefully to learn more where the moon came from. Well, I say nonsense, because the moon's orbit is unique in the solar system. But there's something else about the moon. If you compare the ratio between the mass of the moon and the mass of the Earth, it's pretty high. Earth has about 81 times more mass than the moon does. But when you look at other planets, they have thousands or tens of thousands of times more mass than their satellites have. So when you look at the ratio between the mass of the planet and the mass of the satellite, it's closest for the Earth by quite a bit, Earth-Moon, than it is for any other in the solar system. Now, this is tricky. The Earth, you know, has a tilt of 23.5 degrees. That causes our seasons. But perturbing effects, the other things in the solar system are yanking on that tilt, and over time it would cause that tilt to change tremendously. It would go from being 23.5 degrees to being 0, to being 90, back to 0, waffle all over the place. It would slowly happen, but it would happen and waffle everywhere. What that would mean is that eventually there would be no seasons, and eventually most of the Earth's surface would be simultaneously in the tropics and in the Arctic regions. Could you imagine the devastating effect it would have on living creatures?
Sure.
That's if there's nothing else going on. The planets and the sun and everything else out there would do that to the Earth's tilt.
So why doesn't it?
Because of a very complex interaction of the moon, it stabilizes it and keeps the tilt within about a 2-degree range. You can't leave more than about 2 degrees, which we can withstand that small change. And that only happens if two things are true. If the mass ratio is high, which is unique to the Earth-Moon system, and this is critical, that the moon orbits in the ecliptic plane, not the equatorial plane. And it's the only satellite in the solar system for which that's the case. Now, again, you could argue that's a coincidence, you know, but how many coincidences are you allowed before you begin to realize, well, maybe these coincidences aren't coincidences at all? But, you know, my job as an astronomer and as a creationist is to try to identify these interesting little features. And those are two that just are screaming design to me. I have to keep saying, well, there is design here. I think it's not not happenstance. You know, if this was all a result of some cosmic accident, would you expect that many coincidences to take place? Now, you can talk about the Earth itself, the unique properties it has, its proper distance from the sun, the right kind of mass, the right kind of atmosphere. The atmosphere of the Earth is very curious. It's nitrogen-based. It's what's called diatomic. We have most of the gas in our atmosphere has 2 atoms per molecule. And that's really significant for life, too. In fact, so much so now that people looking for life on planets around orbiting around other stars, they think the important thing to look for is a nitrogen-based atmosphere. That seems to be the gold standard they're looking for. Water. Water is probably the most common molecule in the universe. We see it all over the place. We see it in the atmospheres of cool stars, which I did my dissertation on in astronomy. We also see it in interstellar medium, the stuff between the stars. We see them in satellites, we see them in planets, we see them in comets, we see it all over the place. But always where we see it, it's either solid or it's a gas. The only place in the universe where we know for sure that liquid water exists is on the Earth. There have been claims that might exist briefly on the Martian surface, that might exist below the surface of some of the satellites of the outer planets. But those are just possibilities. It's not been confirmed and may never be confirmed. But we know we have plenty of liquid water here, and we know that liquid water is essential for life. It's you know, your body is like 75% water, and there's a good reason for that. So water, an essential ingredient for life, liquid water, only exists here as far as we know. And that's amazing for something that's so abundant in the universe.
But Danny, that almost takes us back again to the incredible order that exists, not only in just the visible, but even down into the invisible, even mathematics as well, doesn't it?
You know, there are four fundamental physics forces they talk about: the strong, the weak, the electromagnetic, and the gravitational. Except that 35, 40 years ago, they kind of combined the electrical and weak forces. So now we have three. And we've seen this unification of physics before. They want to unify into a single theory. So the belief is that eventually we can wed the strong and the electric and weak forces into one. We call that the grand unified theory, which is GUT for short. And then ultimately gravity, which is the tough one, because it's so much different from the others, weaker than the others. If we can unify that, then we have what's called the theory of everything, TOE. The belief is that there's a simple underlying theory behind everything. And to me, that speaks of design, because we saw these disparate forces, and there's this belief that there's this unity here, but what are you basing that belief on? Well, some experience you've had, but very few physicists seem to be asking the question, well, why is there this simplicity here? And you've got to think either just that's the way the world is for no apparent reason, or the world is that way for a purpose and design. And to me, that speaks of creation. We also see in particle physics a lot of symmetry going on, and a lot of neat little things. For instance, elementary particles seem to come in groups of six. Why six, you know? And there's some unity inside of all of that, and they've filled in this beautiful basic theory of how all this works, again, tied into this idea of simplicity. So we see this order coming out of all of this. And why is the world so ordered? And it's just taken as a given, that's just the way it is. But, you know, philosophically, why? Theologically, teleologically, why is it like that? And to me, that just screams of design in the universe. Just like you were talking before about design in biological systems, we're seeing design in the very fundamental physics of the world around us.
And an order that extends down to the particles and extends all the way.
Smallest things to the biggest things in the universe. It's a wide range, many orders of magnitude, and that's remarkable if you don't believe in a creator.
Yeah, that's true. Danny, when we talk about all of this design, it just makes me think that all of this really was made by God for us.
Sure.
Is that how you see that?
Oh, yeah.
That means we're more significant than what we've heard from other people.
Oh, yeah. You know, back in 1972 or 73, I believe it was, Brandon Carter termed this thing called coined a term called the anthropic principle. This idea that a number of things about the universe that seem to make it ideally suited for our existence. That is, man is here for a purpose and a reason in the cosmos. And Barrow and Tipler wrote a book 30 years ago called The Anthropic Principle. It goes on for 1,000 pages plus, with the whole history, full discussion of all this. And when all is said and done, you know what the conclusion was? The universe just appears designed.
Oh.
And so it's a situation where they were confronted with all the evidence they really needed, and then they just walked away from it, arguing instead it was just appearance of design, not real design at all. And again, I keep saying this, but it comes back, it's not a head problem, it's a heart problem. If you do not believe something, truly do not believe it in your innermost being, then you are going to deny that truth and reality given to you. Many times we just think that if we can just convince people, argue persuasively enough, people will accept it. But my experience over the years has been that people don't want to believe what they don't want to believe.
Right.
You know, with creation, evolution, I've seen people confronted with all sorts of evidence against evolution for creation. They admit you make a good case, but when you're done, they simply say, well, I'm going to continue to believe in this. It makes no sense, because you see, it's not a head problem, it's a heart problem.
Right. Well, Danny, all that we have talked about tonight and all that we have seen, the awe associated with not only the visible aspect of the stars, but even the invisible things we've talked about that come together to make us understand and help us realize that God has made all of this, and the evidence just seems to be overwhelming. And yet, at the same time, we have the reality that in the face of that evidence, people still don't see it. That there is a strength associated with a paradigm that will keep people from seeing what we appear to think is plain.
Well said. Amen.
But there are a lot more stars out here. I'm sure you can.
Oh, yeah. You know, we've been out here quite a while.
Right. So how many of you have seen the Milky Way in your naked eye? Not everybody? No? You gotta go someplace really dark Yeah, it's visible from here, except you can't see it. There's so much light.
So it is a beautiful sight, and you just don't
Oh, yeah.
see them.
And down the canyon, you didn't need anything extra. You could just see it. You can't take your phone out and get a picture of it. Very amazing. And that was, did you catch? And I'll put it in a different way. The reason why Jewish holidays move around in our calendar. See that? Because they follow a lunar calendar. And
And
they're-
of course, each one of them enjoys Jewish. That was the new.
Yes, right.
I didn't mention like, Passover, which started at sundown last Saturday, which was the 14th of Nisan, and ended yesterday. So of course, Christ has already been crucified and resurrected.
Yeah.
And we're celebrating today that his resurrection, so it's kind of. I hope.
Yeah. It's not right.
It's not right.
Something's not right. So we gotta make a mistake when he gave us 365 and a quarter days in a year. Why couldn't he make it an even number?
Well, I guess the Hebrew calendar, they add an extra month. I think every 5 years, Adar is added, so
To straighten out the,
to straighten out, we have
Year.
February 29th, and we have all 30 days, but,
yeah. And so when they give times and dates in the Bible, are you really getting it right? And then all that about the moon, isn't that amazing? I knew our moon was kind of different. I didn't realize it was quite so special. I didn't realize that all the moons don't go the same plane as the solar system spins. But none of them except ours.
It's amazing when you think about it.
And all that other stuff about keeping it on its right tilt and all that. I don't understand that, but.
No more than 2 degrees.
Right, he thinks he sees the physics to it.
Well, what's more amazing, despite all of it, they still say, oh, it just all by chance.
Yeah, just happens.
That's just the way it is.
I wish to believe something. Well, Paul, it was a big explosion.
We'll talk about that in this next video.
Yeah,
You have to
shrink it down.
shrink it down. Just that's it out. And sometimes we welcome to these things.
I'm going for number
6.
this one. No, not my books. No.
Get rid of that video.
Close this. Does it make it easier? Speaking because he's looking. Loves us. Go to. Oh, no, that's right. Did you have another fund in the open?
Should have. Open up.
Is already in.
Huh?
Say it's right here.
I don't know. I can't see very good.
I will start. Then for number 6, right?
Yeah, so it should be at the top.
I got it. This one here. Second. I'll give you one more chance to, anything else you wanted to talk about from that last one? I liked where you ended. People see all the evidence and they just turn away. And that's not a head problem, it's not understanding, it's a heart problem. But I don't understand.
Did he talk about the flood at all as far as the earth tilt? Was it one way before and then now it's this way?
He didn't say anything like that. Let's carry on. Now we're getting to the Big Bang and the light travel time. Are you familiar with the light travel issue? Something's so many light years away, it's a million light years away, that has to be a million years to get here. It is an issue. All right, you're gonna talk about that.
Well,
up
we've had a shift here, and we got the autumn stars high overhead. One of them is back behind me here. We have this M group of stars in the sky. You know, earlier it was a W.
That's true.
But now it's an M, and that's because the rotation of the Earth has caused the whole sky to wheel around the North Star.
Huh.
And as it does, it changes from a W to a 3 to an M. That's the constellation of Cassiopeia,
Okay.
the queen. You're supposed to see a queen seated there. I don't really see that. And then back this way a little ways, we have the Great Square of Pegasus. It's this big rectangle.
I see
not,
that.
Not quite a square, but we call it a square. There are very few stars inside, so it really jumps out at you.
does.
High overhead in autumn evenings. And it's supposed to be a winged horse. This is the body of the horse and the wings sticking out here. Its head is up here like that. And out here, the two front legs. We only have the front half. We don't have the back half. But you know, I've always thought if you're going to have a half a horse,
You better have the front half.
rather than the back half.
Yeah.
That's the constellation of Pegasus. Now, coming off of Pegasus is Andromeda, supposed to be a chained maiden here. Go up a couple stars, there's a little fuzzy spot right there.
I
Do you see
see.
that?
Yes, I
Now,
do.
it's best to use averted vision. You don't look right at it, but you look off to the side. And when you do that, it shows up much better. A little fuzzy patch.
Little fuzzy spot.
That's the Andromeda Galaxy. That is the most distant object that you can see with the naked eye. But it's the nearest galaxy, similar to our own galaxy. It's we think a little over 2 million light years away, and it contains a couple 100 billion stars.
Wow.
So it's a very impressive object in the sky, but you need a lot of aperture to see it well.
Yeah. Okay, Danny, that brings me to a big question, and a big question in a lot of people's minds. If we have stars that are that far away, millions of light years away, and if the Earth is young, as we believe, then how in the world can the starlight be here?
Yeah, we call this the light travel time problem, and I'll try to phrase it for you a little differently. We believe that the creation is only thousands of years old, say 6,000 years, 7,000 years, something like that. And I've just pointed out something to you that we think is 2 million light
Yes.
years away from us.
Right.
I think those distances are reasonably correct. You know, if it's off by 100%, it's still maybe 1 million light
Sure.
years. So
Right.
that isn't going to solve the problem. And by the way, this is just the closest. There are galaxies that are hundreds of millions, even billions of light years away from us. So the question is, as you ask, if the universe is only 6,000 years old, you can only see things within 6,000 light years. How can we see those distant objects? Now, it wouldn't affect most of the stars we see because they're at most a few hundred light years in most cases, or a couple thousand light years. But you know, the situation, Del, is a lot worse than you said. The situation is even worse. Let's go back to the beginning of creation. Say at the end of day 6, beginning of day 7, the sky gets dark.
Yes.
The creation's ended. Adam and Eve look up, the sun sets, the sky gets dark. What do they see?
Huh.
They had to see stars because
Yes.
if they didn't, the stars could not fulfill their function. But the problem is the nearest star outside of the sun is more than 4 light years away. So how could Adam see the nearest stars? We're so concentrated on the most distant objects in the universe, but we really need to think about what Adam saw in the closest objects outside the solar system. If you can answer that question, that problem, then I think the problem we have today is probably answers itself.
I see that.
And we creationists need to answer this question, and we've offered several different solutions to that. I'll discuss with you my solution
Okay.
on this. And I came up with this a few years ago after wrestling with this for years. And I think I was looking for a scientific answer, if you will, a physical answer. But I think several things jump out at me in the creation account. One is that many people think that everything during the creation week was instantaneous. Poof, a tree appeared where there was none. Poof, a whale appears where there was none. But that's not what the text generally says. There's a lot of process going on, very rapid process, but still process. For instance, did God make Adam just poof out of nothing? Well, no, he shaped his body out of dust of the ground. What about Eve? Well, he took from his side and made Eve. That was a process in either case. It was a quick one. It didn't take, hours or days. It happened less than a day.
But it was a
It
process.
still was a process. If you look at the count of the animals, not on the chapter 1, but in chapter 2, it speaks of the animals coming out of the ground giving rise to these things. If you look at the day 3 account, it talks about plants rising up out of the ground. It says, let the earth bring forth these plants, and the earth brought forth. If you look at those words used there in Hebrew, they're very active, dynamic terms. It's almost like these things are sprouting up out of the ground very rapidly. I think if you would have been there, it would have looked like a time-lapse movie. You would have seen growth that might take normally decades taking place in a matter of minutes or hours at the most. Normal growth abnormally fast. Why? Well, in another 2 to 3 days, you can have all sorts of critters and people that are going to rely upon those plants, because it turns out everybody was vegetarian to start with. And if you waited till they normally matured the way they normally do, everybody would have starved. Because, you know, even the fastest growing garden plants take a couple of months to reach maturity. So God had to mature these things fast, rapidly. He didn't make them mature, he matured them rapidly from what the language is telling you there. I believe you can interpret one day of creation in terms of another day. So I turn to the day 4 account. Not much information is given there, but I think God also rapidly made the stars and other astronomical bodies. And then, in order for them to fulfill their function to be seen, he had to rapidly bring forth that light, just as he brought plants and matured them quickly. He had to bring that light here. Now, I'm not suggesting the light was created in transit. That's one theory. You see, if you have light created in transit, the light we're getting from these distant objects didn't come from physical processes. It's like they were holograms or just illusions. I'm suggesting when we actually look at these objects, like the Andromeda Galaxy we saw a few minutes ago, we're looking at light that actually left that object. I believe that the Andromeda Galaxy is about 2 million light years away, but I don't for a minute think that the light has been traveling that long. I think we're looking at the universe in something close to real time. If the light's only a few thousand years old instead of a couple of million years old, well, that's pretty close to real time. So I think there's a rapid maturing took place. Also, I'm not appealing to a physical mechanism. I'm appealing to a miraculous. And some of my creation science buddies have given me a little bit of grief on this, because they're looking for scientific answers for everything. And you can give scientific answers so far back. But you know, the writer of Hebrews, and also Paul writing to the Colossians, talked about the current sustaining of this world by the power of his word. Moment by moment, the Lord sustains this world. I don't know how he does it, but maybe it's miraculous, but he does it in a consistent pattern, the way that God does things. He does them consistently and orderly. And we can study that. In fact, we can write equations that describe it. These equations we have, it's called physics. And so the study of physics is really the study of how the world is being sustained moment by moment. But you can't take that sustaining and extrapolate it back into the past, because eventually you'll bump up against creation in the past. And creation is a miracle. There's a certain point where the miraculous take place. And I think at some point, maybe it's stages, but certainly by the end of the creation week, God went from creating to sustaining. And if we try to push back the current sustaining, what we call physics, into the creation week too far, we're kind of committing the uniformitarian assumption. We accuse the evolutionists of. And I think sometimes we seriously underestimate how the miracle of creation, we might as well come up with the physical explanation for the virgin birth and the resurrection. So, you know, after more than 3 decades of wrestling with this issue, I finally come to peace with an explanation. And it's interesting that a scientist has come around with an appeal to a miracle. And I'm okay with that. And I found many people are okay with that.
Well, Danny, this all makes sense to me. In fact, it even reminds me of the first miracle of Jesus. And if we were to try and take physics and all that we know about wine and try to understand how Jesus created wine in a very rapid moment, we wouldn't be able to do that.
No, and I think that underscores the fact that that science addresses the natural world, and miracles are supernatural. And so you can't use a scientific method to discuss miracles, I don't think.
Well, Danny, do you see any other evidences that would indicate that the universe is really much younger than what the traditional paradigm would tell us?
Yes, I do. For instance, spiral galaxies. The Andromeda Galaxy we talked about is a spiral galaxy. Our own is. It's a pretty common type of galaxy. In their disks, they have this spiral pattern made up of clouds of dust and gas and bright stars. And the inside of the galaxies should spin faster than the outside of the galaxy. So after a few rotations, you ought to wind up or smear out those spiral patterns. They ought to disappear after a few rotations. Now, most astronomers think that spiral galaxies are 10 billion years old. So why do we still see spiral patterns? You shouldn't see those.
Right.
And it's been a long recognized as a problem. In the late 60s, they developed this thing called spiral density wave theory, and that was the answer for several decades that they assured us that it worked, that there were these sound waves propagating through the galaxy that made these things persist. Well, then by the 90s, they were invoking companion galaxies that were stirring things up instead. And more recently, it's now been dark matter that's stirring these things up. So we've had, in the last 45 years, 3 different solutions to this problem. You don't need new solutions if the old ones worked, and they assured us that they did. So I think that's a problem. If we look at the outer planets of the solar system, the gas giants, they all have rings. You know, when we were growing up, only Saturn had a ring system, but now we know that the other 3 have them as well. And we also know that these things are changing, wiping out. We know theoretically they ought to, and with probes to Saturn and Jupiter, they've actually documented changes that have taken place within the ring system. You have all these gravitational tugs from the other satellites orbiting around, and people have estimated that a ring system like Saturn's can last maybe 1 million years or more, just a few million years, with an M, not a B. So these ring systems are fairly young. Doesn't prove the solar system is young, but it proves that these ring systems are young, and that's interesting. You know, in the summer of 2015, we got the first photos from the surface of Pluto, and the big shock everyone had, including me, was the fact that there's a lack of craters. There are a few impact craters, but not many on Pluto. Now, it's been doctrine for decades in the solar system that wherever you see lots of impact craters, it indicates a very old surface, and when you see very few craters, it's a young surface. You've had geological activity that's reworked it, and you can do that 3 different ways. Well, none of them work for Pluto. So it indicates that Pluto is a young object. It doesn't have any way to do this. Now they're trying to figure that out, how in the world in billions of years you can have a young-looking Pluto. Those are the kind of little interesting things that you see from time to time about the planets. We see evidence of rapid processes on the surfaces of planets. Venus, they believe, had a complete overturning of its surface in the not too distant past. They say like 150 million years ago, which is pretty recent in a 4.5 billion year history. But they think the entire surface of Venus was turned over in a very brief period of time, a million years or less on their time scale. Furthermore, you look at Mars. Secular scientists are saying that there was a global or near global flood on Mars, a place where there is no water today. They don't think that could have happened on Earth because, well, they don't believe it happened, but there's plenty of water here. And those are the kind of things indicating rapid processes, much more rapid than many people realize. So I think there is evidence out there. And my job as a creation scientist, as an astronomer, is to identify and discuss those and bring attention to them. And I intend to keep doing that over the years.
Sure. That brings us to what most people see as the big theory concerning cosmology and the universe, and that's the Big Bang. How do you see that? Is it holding up over time?
I don't think so. I think it's getting some problems. You know, I reject it because I'm a biblical creationist, and I don't see any way that you can reconcile Big Bang with the Bible, though a lot of people seem to think that you can. I think the temptation they have there is to try to interpret Scripture in terms of the current cosmological thinking. That's nothing new. That's happened before, as it's turned out, with disastrous results. But I like to compare the Big Bang model to the ruling cosmology of the Middle Ages, what we call the Ptolemaic theory. A man named Claudius Ptolemy, around the early 2nd century AD, developed this theory to explain the motions of the planets. As the planets orbit around the sun, and we orbit around the sun too, it makes for a very complex motion. The planets, as well as the sun and the moon, seem to move in a west to east direction along the ecliptic, the plane of the Earth's orbit around the sun and solar system, actually the plane of the solar system. But from time to time, the planets reverse direction. They go from west to east, back to east to west. We call it retrograde motion. And that was difficult to explain if you think the Earth is the center of things, the geocentric theory like the ancients did. So what Ptolemy came up with is this very complex model where you had a planet not just orbiting around the Earth, but you had it orbiting on a smaller circle we call the epicycle, and the epicycle in turn went around the Earth, and if you adjust the sizes of those 2 circles and the speeds, you can end up with this motion like this where the planet seems to move backwards. And this was the ruling cosmology for 15 centuries, from really the 2nd century up through the 17th century. Now, as new data came along and problems developed so that you had a discrepancy between the theory and the data, they simply altered the theory, added more epicycles to make the theory work and fit. That was,
complicated.
that was the strength of the model, that you could adjust it to fit anything new that came along. Well, it was also the undoing, because it became very complicated. By the year 1600, there were systems of more than 100 epicycles. You had gears on gears on gears on gears, and people realized this is way too complex, and finally it was rejected. And the Big Bang has done the same thing. It's been the ruling paradigm for 50 years, and in that length of time, I've seen tremendous changes take place. You know, in the early 1980s, we had this Big Bang model that seemed pretty mature, and they were convinced that this Big Bang model was true. But since then, a lot of changes have taken place. They changed the expansion rate of the universe, which decreased the age from 16 to 18 billion years to 13.8 billion, plus or minus 1%. They've introduced string theory into the model. This is the thing dealing with particle physics you have to put in. They've introduced dark matter. They've introduced dark energy. They've introduced this idea of cosmic inflation, that the universe expanded very rapidly in the early universe to solve a couple of problems that they have. By the way, there's no evidence for inflation, but everybody believes it happened because basically we're here, aren't we? I've seen in my adult lifetime numerous changes taking place to the Big Bang theory, and it's starting to look like epicycles. It's starting to look like the Ptolemaic model, just as the strength of that model was that you could change it to fit new problems in data. They're doing the same thing with the Big Bang and changing it. You know, they had the COBE experiment in 1989 to 91 that was measuring little fluctuations in temperature predicted in the background radiation, the supposed proof of the Big Bang. And they had predicted fluctuations in temperature and from point to point of 1 part in 10,000. Well, they found fluctuations 1 part in 100,000, a factor of 10 less. And afterwards, they said that the predictions and the actual measurements beautifully agreed. Saying, wait a minute, how can that be? What they did is they changed the model to fit the data once again. You know, if you have rules like that, you can never disprove a theory. One of the fundamental assumptions that the Big Bang is based upon is that there's a homogeneity of the universe, that it's kind of smooth. It makes the mathematics work out easier, by the way. And we recognize that on the local level, it's kind of clumpy. We have planets and stars and so forth, but then you have galaxies, and then you have groups of galaxies and galaxies working their way up. And it's kind of assumed that on the biggest scale that sort of smooths out. But what we found over the last 35 years is that this clumpiness goes up to the highest levels. It's kind of shocking when they begin to realize that. They don't talk about it much anymore. But the problem is we're now really poised to make what we think is the structure of the universe on the grandest scales, and it's clumpy all the way up. And what most people have failed to realize is this negates the very foundation upon which the Big Bang is based. The assumption of homogeneity. It's not homogeneous anywhere. It's been an article of faith that at some level it is homogeneous, despite all evidence to the contrary. And we're seeing it on the giga light year scale now. It's across the entire universe. And so the Big Bang has become the ruling paradigm, and it's becoming doctrine. It's becoming dogma. So much so that more than a dozen years ago, I think in the New Scientist magazine, there was an open letter protesting the Big Bang theory, and it's had hundreds of signatories since. And most of the people signing it are atheists. They're not even creationists. Right? So this idea that the Big Bang model is universally accepted is not true. There are many people out there, well-known people, very famous physics and astronomy people, that have real problems with the Big Bang. So I think when you look at the history of science, the way we've discarded theories over time, we've had theories that were supposedly beyond dispute, and then later on discarded. When you see that lesson from history, and then you want to wed Genesis, you want to interpret Genesis in terms of the ruling paradigm, I think you need to be very careful.
Sure, yeah. Well, all of this, Danny, just brings me back again to the awe associated with all that God has done, the immensity of it.
Yeah. You know, we've been out here quite a while, and the summer stars have kind of gotten out of the way, and the autumn stars have moved across. We're now getting a lot of winter stars up here, and I want to point those out to you. You know, one of my favorite constellations up there are Orion. Do you know Orion? That's a really good one. But it's also mentioned in the Old Testament 3 times, twice in Job and once in Amos. You know, when I look up at Orion, I'm seeing about the same thing Job saw, because those stars are hundreds of light years away, and even though they're moving, they haven't changed in 4,000 years, really. The shape is about the same. But you know, there's a connection I can make to a man that's been gone for thousands of years. But more important than that, of course, is that I should make the connection to our Creator, because God was challenging Job about the fact that he created all of these things.
That's classic Danny, that you get to the end and he's still talking.
Yes.
He's
He
still
talked
going.
all night long.
Oh, he had a lot of energy. Okay. All right. So, man, there's a lot packed into that. So what did he say to say about the speed of light problem?
It's enough time,
Not enough time. Therefore,
not practical.
That brought it forth.
And
You know, the people
the comparison exactly to plants coming from the earth and
mhm,
matured them
right,
in hours of the day.
yeah,
Same way he created the light from the stars, he brought them to maturity all in the same day.
Does they serve the purpose?
Yes.
yeah. He said, essentially, you know, why is it that you can accept all the other parts of the creation account and this one's a problem? It was all miraculous. Miracle after miracle. And the fact that he brought the light here so that we could see it. That's no more of a problem than he made the forests and the plants available for the animals to eat the next day.
I think you were saying also that what we see is old. The planet could be, or star, or whatever, could be
Mhm.
burnt out. But you'd still see the light for a period of time? Because it's so many light years away?
Yeah, all right, that's what we observe today. We can measure the speed of light.
Mhm.
We know we can measure how far away things are, kinda. And so therefore we know that what we're seeing is where that star, what that star was like.
Right, but it's
It was
not real
created.
time.
Yeah,
But even with a telescope, again.
telescope sees the same light in your eyes.
Yeah.
But now all of a sudden we found this way to transmit information instantaneously. I call it action at a distance, but it's instantaneous. To the entangled particles, you hearing about that stuff? No, this is weird stuff. But apparently it's real. They're actually finding it practical application. But they can take these two particles and they do something to them so that they are entangled. And then you act on this one, and this one here does the same thing. But it's could be anyway.
So they can be 10 billion light years away
In theory.
and they both instantly
flip it
flip
together.
back and forth.
Mhm.
So now you can have a communication system or a satellite
Instantaneous.
that's at the end of our galaxy and you can communicate instantly with it.
Mhm. So they're working on an application where it's gonna be used in encryption. So they have a satellite up there and have a receiver down here. And they'll be able to instantaneously transmit encryption data. Encryption keys probably. Yeah, weird stuff.
Well, I know when we were out there, he was talking about stars that
Mhm.
traveled together. They were linked
Mm-hmm.
together, even though they were millions of miles apart. They were still moving the
They were-
same rate, same time, and just moving through the galaxy because they were paired
Yeah,
somehow.
I think they're orbiting each other. I know there's some that orbit each other.
Yeah, but I remember him saying that they actually moved through space just on the
Yeah.
same plane.
Yeah.
So,
Wild. Yeah.
yeah. I'm more into rods.
You're more into rods.
It's confusing.
Some I can touch.
Rocks are easier, yeah.
Yeah.
what astounds me is that God created all that
in an instant.
and we can't see it. And I mean, for all those thousands of years, shepherds in the fields looking up at the stars, well, they only saw just a fraction of what's out there. We got those space telescopes out there now, and they can go point those things at the darkest spot in the sky they can find, and it's full. Galaxies, stars that you just can't see. You gotta put all that out there? And we can't even see it? It's out of our reach, we can't even get there?
They supposedly found the edge of it.
That's what I heard.
Well, yeah.
That there is an
Gotta be
end.
a long ways away.
And he made a universe that big for us. By the same token, there are things you get your microscope out, you know, and you can look down in there and there's stuff in my water and it's moving. Amazing. And you keep looking and it gets more and more detail. You find, you get down to the scanning electron microscope and you're seeing the tiniest details and it's still amazingly orderly.
I saw something that our bodies are particles that aren't really. There's space or something between them.
Yeah, right.
I'm like, what?
Yeah, full
Yeah.
of holes.
Yeah.
Yeah, how- if that was the case, you'd be able to go through the wall, I don't know.
Uh-huh, and some people think that.
Yeah.
If I do this enough, my fist will go right through.
I'm surprised you didn't mention anything about. I don't remember the exact term for it, but these dead holes, they were.
Oh, the black holes?
Oh, black holes, yeah.
They didn't
Yeah.
mention anything about that.
He did not know. I know that he does have things to say about it. I've watched some of his other stuff. Congressman Tolkien. He's got a couple books that could remind you to do it.
Yeah, he talks about the Bethlehem star,
Yeah,
all of the different options. for
Uh-huh.
those.
what option? You can come down with,
He came down, there's
some kind of glory, yes.
Mhm.
kind of glory.
It's God's,
It's the same star that led them out of Egypt.
yeah, God's light.
Yep. But there are several other options that he discusses. But that's the one he came down with, yes.
You heard also in his creation discussion that he sees that things were done by a process. He could have just come and they're there, but he didn't. He formed them from the dirt. And the animals came out of the earth. And the woman came from man's rib. Made her special. So there are processes that sometimes maybe there's something to be found about that process. Maybe there are things to be learned. That's just kind of aids. Puts that thirst there to learn more. But you just can't put the thirst at the very peak, okay? The thirst is supposed to guide you to him, not puffing yourself up with knowledge. And that's what impressed me about Danny was that, you know, he went through this whole thing about, I think I asked him about the speed of light, he went on about this and came down to, well, it's really becomes a question of faith. He did all these other miracles. Why is that miracle a problem? And if everything is a process that I can reproduce, then what about resurrection? Yeah. Some people think that they can bring back the dead. They're working on it. I don't want to come back.
Yeah, that's right. Or I'm gonna be, I don't want to.
Don't experiment on
How
me.
disappointing would it be?
I finally graduated, I want to stay.
But on a trip, he didn't sleep much, and neither did I, because I enjoyed getting up and. I watched the night sky.
I missed
See,
a
I
lot of
didn't
those
see
nighttime
Jim on.
sessions.
Mhm.
3 AM. I'll get it. It was an exhausting trip. Anything else you saw I want to talk about?
No, it's a good thing that the scientists now are questioning these old theories.
Oh, yeah,
Yeah, because before it
somebody's
was,
questioning.
it's science, it's
Yeah, right.
it's stone, you know, that's it.
Do you like his conclusion that, well, we're here, aren't we? Must have happened.
I wish people would look at that.
Yeah.
Wish to look at that instead of just learning everything from Star Trek or something, you know, Star Wars.
Well, he said it a lot of times, it's a heart problem.
Yeah.
It's not a mind problem. I mean, all the information in the world, like we've been learning over the last several weeks here, there's a lot of evidence that it's a young earth. You just can't dispute it,
Mm.
but they cling to it.
An analogy for Big Bang Theory, I'm gonna blow up my house so I can get a new one.
It'll just assemble.
Just gonna come back.
It'll blow up and it'll come in.
Comes back.
One in addition off the back, just a small one.
It's like
not gonna
you
happen.
go to build a new house, do you go and find a contractor, and you go down to the local store and buy some dynamite?
Yeah. Dynamite sounds like more fun.
Yeah, it is fun.
If I want to live in a cave, maybe it's a good idea. Oh. Well, and the thought that he did it all for us, that just, that's the extent of something. I'm like, don't want to be late. So it's close. Now, Father, it is astounding what you've done. Your creation is just amazing in its detail, to the largest scope to the tiniest. You've given us the ability to research these things and learn and see what you've done. And Father, we want to give you all the glory for what you've done. The amazing detail. And for making us such a gigantic home. And today we celebrate the miracle of Christ's resurrection. New life in him. Let's keep our hearts focused on you. Extend our praise towards you this morning. Bring your son, in glorious name. Yes.